Anyway, we're in our sequence. Actually, we're in our main right now. Let's go ahead and close out of main. And I'm going to work ladders to start. So let's go ahead and pull up ladders. And I'm going to pull up my modes in ladder as well, because I think I'll probably need to work with both of those. And I'm going to just delete out all that commentary because I don't need that anymore. Okay, so what happens whenever we start getting some of these alarms? Well, let's start with the more dramatic one here. Let's start with e-stop. Now, the conditions for e-stop basically are exactly the same as idle mode. So if we get an e-stop, basically what we want to do is we want to skip through every transition, and we want to make it so that the only place that we can be is idle mode. All right, so let's come up here and we're going to go through these transitions. So we don't want to engage the start bit, but the warm-up transition, we want to make sure to just immediately transition right out of that. So let's come down here and throw in another branch. And this is going to be for our e-stop alarm. And if the e-stop alarm is engaged, then we want to just jump right here to the end and always be energizing that warm-up transition. And same thing for the stabilized transition. Another branch, another normally open contact, looking at the e-stop alarm, and if it'll let me select what I want, we're going to just generate a bridge right straight to that transition. And same thing for generate. One more of the same, looking at e-stop alarm and going straight to the transition. For cooldown, same bypass. E-stop alarm and straight to the transition. So now the only place that we can be is in idle mode if we have an active e-stop alarm. And let's go ahead and do the same thing in the rest of our modes. So I'm going to open up my modes function block, my modes SCL, and my modes STL, and I'm just going to work through those the same way. So for my function block, I'm looking for a warm-up transition here, and I'm just going to go through and let's take my bit logic and add, oh, not an AND, let's Control Z. I'm going to get an OR. So let's go ahead and grab an OR, and we're going to be looking for an e-stop alarm, and that will also transition us out of there. For our stabilized transition, same thing. We're going to take an OR looking at e-stop alarm, and I'm going to try this. I'm going to try and copy that block and see if I can just paste that in. Oh, that works perfectly. How nice. Cooldown transition. E-stop alarm will engage that permanently, and yep, that brings us right back. So okay, that's 2 languages done. Let's go for our SCL, and else we've got warm-up transition. Okay, so I'm going to come up here and I'm going to add another condition, e-stop handling. And if e-stop alarm, then, and I'm going to engage all of my transitions. So it's going to be warm-up transition, colon equals 1, semicolon. And let's copy that. And I'm going to need stabilize, generate, and cool down as well. So where is it? Stabilize transition, generate transition, cool down transition, and if, semicolon. All right, so that will engage all of those transitions automatically. And if it doesn't do that, then I'm going to engage all the rest of this logic. So we're going to say else, come down here to the very end, and end underscore if, semicolon. Okay, so if we hit the e-stop alarm, we're going to do, we're basically just going to set those transitions, and the only thing that we want outside of here is we want our idle mode outside of here. So let's Control X and get rid of that. Come down here at the end of this end if, and then we're going to put our idle mode on the outside because we always want to engage that logic. Okay, and I will respace this. There we go. About like that. Okay, so that should do it. If we don't have an e-stop alarm, then we're going to come in here and we're going to do all this logic. Otherwise, we're going to set all the transitions to 1, and we're going to jump out here to idle mode. Yeah, it's kind of a hack way to do it, but I think it'll work. And for our STL, I bet we're going to have to end up doing something similar. So let's start right here on this line, and let's define a label. So that'll be, actually we've got warm-up mode right there, and I'll just create something right here that says start warm-up. That'll be a label. And before that, we're going to put our e-stop handling. So e-stop handling, and we'll call this label e-stop, even though I really don't think we need a label, but just in case we end up putting something before it, why not, right? So the first thing we're going to do is we're going to say and e-stop alarm to see if we've got an e-stop alarm, and if so, we're going to JC, jump conditionally, to e-stop transitions. Otherwise, we're going to jump unconditionally to start warm-up. And then we need our e-stop transitions. So we'll go ahead and create that label here. And what are we doing with these? Well, we're going to load set into our register, and then we're going to set our warm-up transition. How did I get down there? We're going to set our stabilize transition, set our generation transition, set our cooldown transition, and that should have us into idle. Now, the one thing that I'm not sure about is, do we have the interlock? Are we looking at the interlock in our cooldown or in our idle? And yes, we are double checking and making sure to reset our interlock. Okay, so that should be it. That should be good here. Now we've got our first alarm done with all 4 languages. So let's go back to our modes ladder. And what else do we want to look at? We want to look at what do we do if there's a oil high flow alarm. And this is going to be an organization block, cyclic interrupt, and we're going to have this be our PID. Now the PID instruction, we are not going to do that in all of the different languages because there's really no value in it, I don't believe. So For this guy, we're just going to have one organization block doing the cyclic interrupt, not 4 different blocks all interfering with our process. We're just going to keep it simple and do this in ladder. And so let's hit OK and create that. And it's thinking. It's taking its time. All right. So up here, this is where I'm going to go ahead and do that set point. So first thing we want to look at is we want to see if we have an oil high flow alarm. And if we have an oil high flow alarm, the first thing we want to do is we want to grab whatever our oil set point is going in right now. So let's do our move. And what we're moving is our VFD set point, whatever that is. And actually, instead of doing a move, let's just cut out a step and let's do a divide. So let's bring in a divide block. Cut that, delete that. We don't need that anymore. There. And we're going to divide our VFD set point by 2. And that's going to be our override. Well, we'll call this HOF, high oil flow, override, VFD set point. Okay, kind of a big obnoxious name, but that's all right. And let's go ahead and leave that as a local temp int. And then in the next rung down, we're going to move that value into the VFD set point. So once we have a high oil flow alarm, we only want to do this once, because otherwise we're going to divide it by 2 every single scan. And that's not cool. So let's go ahead and give ourselves a storage bit for this trigger. And that's going to have to be local static. It's going to have to be global because we don't have database on this organization block. So global memory, and in that case I'm going to call it an ONS. So ONS 5, right click, define, and that's going to be global memory bool. Okay, so we have a storage bit and we're only going to divide it by 2 one time. And from that point forward, we're going to take that override, and you know what? We should have made that global after all. So let's go ahead and delete that out of our temporaries. And let's get rid of that pound sign. And let's define this as global. Okay, so once we've got that, now we want to come over here. And now we want to do our move. And we're going to basically put this right back where we started. So we're going to move that value into our VFD set point. So from that point forward, whatever this value is, which won't be affected anymore, that is going to remain our VFD set point value. And the only other thing we want to look at is we want to make sure that our alarm is active. Because if our alarm is active, we don't want this override happening. So I'm going to go ahead and give a comment right here. High oil flow alarm handling. And maybe down here we'll put our actual PID instruction later on. So with just this right here, I think we've got our high oil flow handled. So no matter what language that happens in, I think we're good on that one. So let's go back into modes on the ladder. Now we need our oil low flow alarm. For that guy, it's basically going to be just like an e-stop. We're at a point where we're going to damage something very quickly if we don't take an extreme action. So the same thing for e-stop. We're going to handle this by basically just slamming ourselves into idle mode. So And we're also going to lock out our VFD. So let's go into, first of all, let's pull up I/O for all of our languages. So STL, SCL, ladder, and function block. And where we're energizing this right here, we're going to go ahead and throw in an AND. So bit AND. We're going to look for oil high flow alarm. And if we've got that, we're going to say do not energize this. So as long as that high oil flow alarm is not present and all that other stuff that we had, we'll go ahead and energize that output. Let's go into ladder. And right here in the middle, I'm just going to go ahead and actually this should be normally open contact, and we're going to look for that oil high flow alarm. And we're going to look for that oil low flow alarm. And did I get oil low flow on this one? Actually, I put high flow. That needs to be oil low flow. All right, so, man, that's not what I clicked on. Come on. Oil low flow alarm. Okay, so now we've corrected it in our function block. We've got the interlock on our ladder. Let's move into SCL I/O. And here's where we're energizing. So let's go ahead and say if that HOA is 0 or it's equal to 2 and we have that, and we're going to have one more or. So that's going to be if oil low flow alarm, and come on, where is it? Oil low flow alarm, or HOA is in 0. Okay, so if we have that alarm, that's going to slam us into 0. And right here, even with these conditions, we want to make sure that those conditions don't override this. So let's go ahead and put this whole thing into parentheses. So we're going to say any of those things and not oil low flow alarm. Okay. So now we've got it handled in SCL. We've got one language left on this, and that's STL. And we're looking for the set. So right here, we're jumping to set or reset. And for the set, we want one condition. So we're going to say and not. And that's going to be oil low flow alarm. And if we get that, then we're going to go ahead and set that. And let's put that up on that line. Good. And for resetting, we're going to have one more potential jump to reset. So we're going to load, and that's going to be our low flow alarm. So where is it here? Oil. Come on, I know it's here. Man. Oil, low flow. Oh, come on. Okay, fine. If it doesn't want to pop up there, I'll just copy it from down there. Oh, it's because I've got load, not and. Okay, so and oil, low flow alarm. Great. When you type the right command, it works like it's supposed to. In this case, we're going to jump conditionally to reset oil. And if we don't do that, then we're going to just proceed on normally. And if we do that, we're going to reset that, set it to 0, and jump to break. Okay, so now we've got that alarm handled in all of our languages. Let's move down to, I click on it and it disappears. Siemens, fix your freaking software, please. Okay, now we're looking for our overcurrent alarm. And essentially, if we hit that, we want to jump straight into cooldown or idle. So when would we have overcurrent? Let's go into, we'll start with our ladder, and we're going straight to generation mode. So here it is. And when do we transition out of here? If we have an e-stop alarm, and we're going to add one more condition, and that's going to be an overcurrent alarm. And either one of those is going to transition us immediately right into cooldown. So that was easy. Let's go into our function blocks, and let's come down to generation. And here we're going to bring in an OR. So if all that stuff happens, and actually no, we've already got an OR right here. So we're just going to add one condition to that for overcurrent. All right, that was easy. Let's move into SCL. So let's find our generation logic. Okay, here it is. And we've got if generation mode, then do all of this, otherwise go here. Well, we're going to say if generation mode and not our overcurrent alarm, then do this, else we're going to transition out. So right here under where we're doing all this, we're going to just basically give ourselves one more if statement, and we're going to say if overcurrent alarm, then, and here's where we're going to do our generation transition, colon equals 1 semicolon and underscore if. So that will jump us right out of there immediately. And last, let's go to our STL, and we've got e-stop handling up here, which is going to engage all of these e-stop transitions. And we can go ahead and do one more and put in that transition, but I think it'd be easier to do that from within the logic. So let's come into our generation mode, and here we are, generation exit. So we're going to say station interlock and somebody pushed the push button, then jump to generation exit. And then we're going to clear out, and we're going to say and overcurrent alarm. Then we're also going to jump conditionally to generation exit. There, handled. So let's go back into modes on our ladder. And what's next on our list? Our overspeed alarm. Guess what? We're going to do that exactly the same way as our overcurrent. We're going to do all the exact same stuff. The only difference is this can happen pretty much anywhere. So no matter where we are, we want to throw this thing into cooldown. And for the warm-up mode, where is the transition out of there? Right here. So we've got e-stop, and we're going to add one more, and that's going to be overspeed. And that will, man, click on what I want. Okay, that's going to enable that transition. For stabilize, same thing. One more possibility being overspeed alarm, and that's going to engage that. Generation, one more possibility, overspeed, not notify, but alarm, and that's going to take us out of there, and then we're in cooldown. Okay, let's move over to our function blocks, and we're in warm-up. So we've got an OR on our e-stop. We're going to add one more OR, and that's going to be for overspeed alarm. Down to stabilize, one more condition on our OR, overspeed alarm, and generation. one more condition, and overspeed. Done. Let's move over into SCL. And here we're coming into our warm-up mode. And down here is where, okay, let's see what conditions we have. If E-stop, then okay, we're not worried about E-stop, so we're coming into here. We've got one self-contained if statement. We've got another one right here, and this could potentially set us to a transition of 1, but we're not going to worry about that. And we're just going to throw one more if statement right here. So that's going to be if overspeed alarm, then, and here's where we're going to do our warm-up transition, colon equals 1, semicolon, end underscore if, semicolon. And let's copy that logic because we might need to put that in after stabilize. So yeah, we'll just pop that right here. And now we're going to do the same treatment for our stabilized transition. And for generation, we already have it. So we're just going to say or overspeed alarm. And either one of those will engage that. And last but not least, we're going to go into STL. And let's go to the bottom of generation. How did we handle that? We basically had a clear, and then we were loading that after the possibility of going to generation exit. So let's go ahead and copy that. And we're going to go up here to warm up, and we're going to just work that same thing all the way down. So here we could go to warm up exit as one possibility, and now we're going to give ourselves another possibility to go to warm up exit. Otherwise, we're going to jump to stabilize. Then once we're in stabilize, here's our possibility of going to the exit. So let's add our logic in there. And now instead of going to generation exit, we're going to go to stabilize exit. And once we're in generate, and we already have that logic, so we're going to just add one more possibility to what's already there. So we're going to clear, and we're going to look for, actually we needed to make this overspeed alarm, didn't we? Then we're going to jump to generation exit, otherwise jump to cooldown mode, and let's copy that generation exit, come back up here, and let's copy that overspeed alarm, come back up here and make sure that that's what we're using. So yeah, instead of overcurrent, that should be overspeed. And right here, instead of overcurrent, that should be overspeed. And I think that's got us. Okay, let's go back to our modes ladder. And we've got overspeed, and we've got high oil temp, and I don't remember, did we do brake failure already? Well, let's worry about high oil temp for right now. For high oil temp, we're going to throw this thing into cooldown mode. So let's come back up into here, and where are we? Here's our warm-up mode. So to transition out of here, we're going to add one more possibility. That's going to be high oil temp alarm. And that's going to throw us out of warm-up. That same thing would throw us out of stabilize. So high oil temp alarm. Got it. And that would definitely throw us out of generate. So get our high oil temp alarm and connect it up. Okay, let's jump into our function blocks. Warm-up mode, another condition down here, and that's going to be our high oil temp alarm. Another condition to transition out of stabilize, high oil temp alarm. Another condition to pop us out of generate, high oil temp alarm. And let's move to SCL. So once we're in warm-up mode, down here at the bottom, if overspeed alarm or high oil temp alarm. And let's go ahead and copy that. Come down here to stabilize, paste that in. Come down here to generation. And where is it? I know we had it in there. Yeah, if any of these things, okay, that's our fault mode. And, oh, I'm looking at cooldown. That's the problem. So we need one more condition for generation. And there it is. So any of those three will kick us out of generation. Perfect. And STL, that's our last one. And we're in warm-up. And we've got some conditions to take us out of here already. So let's come down here, and that's what we want to select. So we're looking for the overspeed alarm, and I'm just going to put in an OR for the high oil temp. So I'm going to say OR, and that's going to be our high oil temp alarm. And let's copy that. And we're going to use the same thing on stabilize and generate. So down here, we're looking for that alarm or the other alarm. And for generation, we're looking for that alarm or the other alarm. Okay. And we're done with that one. And let's go back in here, and the next one we have to do, the last one, is break failure. And break failure is going to work basically the same as e-stop, because that's pretty critical. That's going to throw us into idle and not really let us do anything else. So same exact thing. Come up here, one more rung, looking for a break failure alarm. And we'll drag that up here. And I'm just going to copy that control. It's going to make life a little simpler. Here we go. Drag that up. Generation mode. Got it. And even cooldown mode, we don't want to be in cooldown mode for this guy. So take us right up there, and that leaves us in idle. Go into our function blocks. Warm-up mode, one more condition to transition out is break failure alarm. Let's copy that and add that to the rest of our possibilities for transitioning. So there was stabilize, here is generation, and last but not least is our cooldown. Got it? Moving into SCL. If e-stop alarm, we're going to basically enable all those transitions, or break failure. We want to do all the same stuff. Done. And now we've got our STL. We've got e-stop handling. So it's going to be we're going to AND e-stop alarm or break failure alarm. And we'll do the same stuff in here. So there we go. I think we now have all of our alarms done. And the only thing I think we forgot is an inhibition. We want our E-stop to inhibit the interlock and the VFD. So let's go into our I/O, and E-stop alarm needs to inhibit the interlock. So where is our interlock? And here we go. We're setting the VFD. So we're looking for and not that. And we're also looking for and not E-stop. Okay? So E-stop is going to inhibit that. And we also want the E-stop to inhibit the interlock. So let's come down here to our set interlock. And here we go. So we're going to say and not E-stop. Okay, it doesn't let me put it on the same thing while that's there, so fine, get rid of that. Okay, and not E-stop alarm. Then go ahead and set the interlock. And I think that's got us for in there. Let's come over here to our SCL, and let's see what we've got. So we've got our VFD right up here. And if all of those things, and that's going to set it to 0. So we're going to add one more thing here, and that's E-stop alarm or oil low flow alarm or blah 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 blah. And we're going to add one more and not here, and not E-stop alarm. Got it? Let's move into our I/O ladder, and for our VFD, one more not, and that's going to be our E-stop alarm. And for our station interlock, where did it go? There we are. We want an and not E-stop alarm. Okay, last language is our function blocks. We're going to say one more negated and that's going to be our E-stop alarm. And for our station interlock, we're going to bring an and into there and check it against the E-stop alarm, and let's make sure to negate that condition. Okay, and when we were doing our STL, I think we missed one piece of that. And when we were putting in that E-stop inhibition, we said don't let it set, but I don't think we evaluated that to actually kill it. So right here we've got the if there's a low flow alarm, then reset the oil pump VFD. And we also need one more jump conditional right there. So let's copy that and clear out our register, Control V, and we're going to say and E-stop alarm, jump conditionally to reset. And let's go down to our station interlock. Once we start evaluating this, we're going to just Control X that for the time being, and we're going to say and we should probably start with a clear, but we'll try it, it might work. And E-stop alarm, JC to station interlock. Oh, that's going to be reset station interlock. And then let's go ahead and put our load back in there. All right. So for the station interlock, we're not setting it if the E-stop is active. Okay.